Silly girl. She's so sassy.
What you put pause?
I can't add like something else. We need that.
I can't.
It's okay. I'll just here.
Here.
I'll be there with tomatoes. Over here.
Too late.
All right. What you up to over there? All right, guys. So there's a question. This one about chocolate chip cookies. So now I want cookies. Sounds good. She wants to double the recipe. Okay, so it calls for 3/4 cup of brown sugar. Sounds good. She wants to double the recipe. How much brown sugar will Imelda need? So, yeah, multiply by 2. So, how do you do 3/4 times 2? Well, I can't be writing on that poor person's paper. How do you do 3/4 times 2? Shoot. Yeah, it's just. I'm trying to find a piece of paper that I can use. There we go. All right, guys. So if the recipe normally calls for 3/4 of a cup, and she wants to double it, 3/4 times 2. Well, every whole number is over 1. So 3/4 times 2. 6 over 4. Now, what can you do? Reduce. I like it. How do you reduce this? Yeah, you can divide the top by 2. So it'll be 3 over 4 divided by 2 is 2.
Can I do it like at the
Now,
beginning?
right here. Yep. Here we go. Today's interesting already. All right. Right here, you might notice that 2 goes into 4 twice. 3 times 1 is 3. 2 times 1 is 2. That's a much better way to do it. So in general, it's better to reduce before the numbers become bigger.
I did a few reducing on 4.2 and 4.3, so you want deduction for that.
What happened? I'm sorry?
No, because I did the same thing. Before I converted, I deduct all of them.
Oh, hell yeah.
That's okay? Okay.
Yeah. You can reduce first and then multiply, or you can multiply and then reduce. Why would it be better to reduce first, maybe? Like, for example, if I had this, 12 over 81 times 27 over 144. Oh my God.
Yeah, this is 12.
I mean, 12 times 27, 81 times 140, those are going to be huge numbers. And then I got to reduce that. Screw that. What goes into 27 and 81, believe it or not? Oh, sure, let's start there. 9 goes into 27 3 times. 9 goes into 81.
9.
What goes into 3 and 9? 3. 3 divided by 3 is
1.
9 divided by 3 is 3. What about here?
12.
144.
12.
So you get 1 times 1 is 1. 3 times 12 is
36.
36. So it's much easier to reduce first instead of reduce last. Reduce before your numbers get huge. It makes so much desperate sense. Okay, I like it.
What about the diagram?
What about part B? Oh, it's as a mixed number also. How do you write 3 halves as a mixed number? 2 goes into 3 once with 1 left over. Left over 2. So 3 halves is 1.5 cups of brown sugar. Brown sugar.
Is that
What's that? Sorry?
I didn't write down cups, so I have to write down cups.
No, you're fine. Yeah, it's mostly the number, but you know. are probably right on their cups. You always put units, yes.
So if they left it as 3/2, would that be wrong?
Only because they say write your result as improper and as a mixed number.
So you have to do both.
Yes. If I don't say, you can leave it either way. So on a test or a quiz or something, if I don't say, you can give it to me either way. I will sometimes say, leave your answer as a mixed number, or I'll say there's a proper fraction. Just make sure you can do that. Cool.
What about the timer?
Just tell those people, I'm in math class, man. Stop be testing me right now. It's no good. Alright. Part B. Oh, jeez. I'm competing with this woman next door again. I'm going to win, lady. Alright, let me see. So measuring cups. She's got to stand right next to the door.
I just like open the door and
She wants me to get upset. Usually come in sets of these cups, right? Draw a diagram to show two different ways. Now I love this question. This is a very wide open question. So she wants to have 1.5 cups. Well, the easy way to get 1.5 cups is to use what? Probably 1.5. That's crazy. Now I'm not gonna. Now you got to come up with one more way, and don't say anything. I'm just gonna leave that open. I'm not even gonna show you. You just kind of come up with another way to get that to happen. So don't say it. Hold on to it. If you can't, and that's the only problem you have trouble with, great, turn it in. I'll tell you later. But right now I'm not going to say a word about it. You guys got to come up with a different way to get it. Sort of feels like that scene in that one Die Hard where they put the water in there. Put the water. No? No Die Hard? Yeah, I see it. You remember that? All right. Yep. Just say yes and you remember.
I have a question
Yes.
on the 4.1, the last one, the 72.
72?
I got confused. I just wrote 1/5, 5 steps, and 4 steps, 1/4. I got
Well, there you go. Yeah, this one's not as it's not as evil as it looks. Yeah, one counts 1 step, and 1 2 count has 2 steps in the count. So 1 count has 3. So how many steps would a 1/5 count have? 1 step 5. I mean 1 5, right?
Yeah.
And so 5 steps, and then what kind of count has 4 steps in it? 1 4. Exactly. Any dancers in here? Is this how they say it? Or what's
It's usually
Oh,
it usually
the
goes in
dancer.
four counts.
I'll make.
Usually it goes in 4 counts.
Okay, but this is possible.
It is.
It would be really weird, but it's possible.
Most people don't do 2 measures. It's
Like 4 and 8.
awkward. Yeah, it's usually
Okay.
4 and 8 count.
All right, but you could have some weird little piece of
Unless
choreography.
you're on drugs.
All right, so this involves drugs. Okay.
I did one more question on 4.1, 48.
Okay.
I just didn't know exactly what you
I'm not advocating drug use, by the way. If you want to dance and use math, it doesn't always require drugs.
Hey, caffeine's a drug.
This is true. Exactly.
There you go.
So there are legal drugs out there.
I didn't know exactly what you want. Like, that confused me.
All
I
right.
know, because it says like a diagram, you know?
I like. You can use figures or algebra, right?
Or algebra.
So I'm sorry. I'm looking at the next one. What's this one say? Use fraction tiles or draw a figure to find equivalent fractions. I'm a little more open than that. I mean, this is if you don't need the assistance of a figure, that's an assistance type of tool. You can just figure this out by yourself.
Drawing 1/4.
Well, watch. Again, the images they use, the fraction tiles they talk about, and the images they use are all to help you.
I understand that, I get it.
But 3/2, really what this is asking me is 3/2 is how many fourths?
Remember what?
48.
40.
3/2 equals how many fourths? No, it can't equal 3/4 because 3/2 can't be 3/4. That's impossible. They're 3/2. So don't overblow this. How do I make 2 become 4? I multiply by 2. So what do I have to do to the top? Didn't we just do that?
So what?
Didn't we just say that 6/4 equals 3/2. So 3/2 equals 6/4. If you can reduce, you can build back up also.
I just didn't know if you were, I mean, I guess practically it would make more sense. Like 1/4 plus 1/4.
Oh, I see. No, yeah.
See, that's where I was going with it. Like
You
1 meter
could do it
complex.
that way,
You
but
don't need
it's
to map it out.
yeah,
Like,
it's
1
more
meter,
like
1/4,
guess and check.
1/4, like,
I got you.
that's why I went.
But real quick, just to show you, 3/2 would be like
That's another way I was thinking.
this, right?
To draw it out, yeah.
That's 3/2. Is that cool?
Yeah.
That's what I did.
Okay, sure. And then, so to make it force, it gets a little bit, well, it's not that bad. To make it force, what would I do with each of these halves? I would just, so 1, 2, 3, 4, 5, 6, force. So that's the model of this. 3/2 is 6/4 because when I chop them in half, I get double all the parts. Does that make sense? I heard a no. Did I hear a no? Or what's up?
Huh? Number 48, right?
Yes.
I wrote this one really weird. I don't even want to say it.
So are you cool with, how did I draw it? Give me. This represents 3/2. Is that cool? Because how much is this part? How much is just this? 1/2. So that's 1, 2, 3/2. Let me stop there. We got to be on the same page with that. Is everybody cool with that?
I'm cool with it.
All right, because this is half. So how many halves have I shaded? 1, 2, 3 of them. So that's 3/2. I'm not sure what's happening. So 3/2 is what we're working with, and we're trying to convert it into some amount of fourths. Right? That's what this is asking me. So I have 3/2. That's what 3/2 looks like. Now, how do I make it into some amount of fourths? Well, what do I do to halves to make them fourths? If I cut a pizza in half, I have halves. So I got to cut it in half again. So if I cut these in half again, now what do I have? 1, 2, 3, 4, 5, 6/4. That's why 3/2 is 6/4. They're the same thing. And on one level, so the picture is kind of nice to see, because it's nice to see something you can kind of like hold. You can imagine holding this thing and cutting pizza or whatever you want to think about. But then the algebra just says, well, of course this is true. I can reduce and I can build. I can multiply by 2, multiply by 2. So algebraically they're equal, but here's a picture of why they're equal. What's up? How we doing?
Good. I get it.
All right, let's do one more. So let's say 5/3 is how many sixths? So how could I draw a picture that represents that? Cut this into thirds. I like it. How many am I going to shade? 5, because I want 5/3. 1, 2, 3, 4, 5. That's 5/3, right? What are we doing? Now, to get 6, what do I do to each? Visually. Cut it in half. So now I got 6 here, right? I got 6 parts. I've cut this one block into sixths. So now I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sixths. And of course, mathematically, it makes complete sense. That's all I'm doing is multiplying top and bottom by 2. Yes, this is the opposite of reducing. This is building a fraction up. When do we have to actually do this in practice, in like algebra? When do we have to be able to do this? All right, we're going to find out today, I guess. All right, maybe. Yes, sir. Sure.
So can we just multiply and get an answer right away instead of doing all?
The problem said to do this, right? You with me? So this is, it's kind of nice to be able to see this so you know exactly what's going on behind the scenes here.
48.
So when we multiply, we get the accurate answer, right?
Doing another.
That's right.
Okay, making sure.
Okay. But anytime you do something to a fraction, there actually is a physical representation of what you just did. So it's nice to know that. This is a physical representation of building a fraction up by 2. What you're really doing is you're doubling all the parts. You had 3 parts, now you got 6 parts. Which means you're also going to double the amount of those parts that you've got shaded in. Because you're cutting everything in half. So now there's like twice as many. They're all smaller, but now there's like twice as many parts.
So if I cut up a dollar bill, do I get more money?
Try it and tell me what happens.
No, but you can sit in federal prison for it.
I hate that.
Check. I see you in the corner. Hello, we together work. Camo,
I mean,
camo.
gas, so.
2, 4, 6, 8,
Okay.
14 years.
Maybe. Alright, any other questions from homework that I can give this poor girl back her copy? She doesn't believe she's going to do it. I guess. Alright, now. Okay. I like this. Can you tell me between what two numbers would you find 2/3?
0, 1.
All right, yeah. Why is that? Is 2/3 is 2/3 equal to 1? How many thirds is equal to 1? 3/3. So this is a little less than 1, but it's definitely positive, so it's more than 0. So on a number line, if I wanted to be really precise, how many parts can I break up in here to find 2/3? 1, 2, 3. Now watch this. This is 1/3, 2/3, 3/3, which is 1. So when you look at a ruler, that's what they're doing with all the little tiny tick marks in the middle. They're breaking it up into smaller parts. So 2/3 would be right there. A little bit less than 1. What about 5/4? It's a little bit. What force would be 1? How many fourths would be 1? 1/4 is way less than 1. How many fourths do you need to have a whole thing? 4/4. I like it. So if you had a little tray and it had 4 spots in it, how many would you have to fill up so the whole tray is full? 4 of them. So if I had, how many 12ths is 1? 12 12ths. How many 80ths is 1? 80 80ths, right? Because something divided by itself is 1. So I know this would be 4/4. This is how many fourths?
1. Oh, the
8/4, right? Isn't 8 divided by 4 2? So 2 is 8/4. How could I have 2 of these trays? If I had 2 of these trays, all full, how many fourths is that? 1, 2, 3, 4, 5, 6, 7, 8. But we know 8 divided by 4 is 2. So on one level, fractions are just freaking division problems. It's just that they're weird to us because we get answers that are between whole numbers. But some fractions are whole numbers. Let those be nice. So where's 5/4? So that's 4/4, 5/4, 6/4, 7/4, 8/4. Careful, not halfway. Halfway would be 6/4.
No, the first one.
Yes, this one, that's 5/4. So again, you've got to know that 5/4 is bigger than 1. We all have to be on that page, right? How do I know 5/4 is bigger than 1?
Because
The top
the top larger than the greater.
is bigger than the bottom. How do I know it equals 1 if the top equals the bottom? How do I know it's less than 1 if the top is less than the bottom? Okay, good. So 5/4 is just a little bit bigger than 1. And to make it easy to graph this, make it a mixed number. How do I make that into a mixed number?
Divide.
Sure, 4 goes into 5. 1's with 1 left over. So 1 and 1/4. So improper fractions you can graph by making them mixed numbers. It's a little bit easier then. So then now think about 12/5 that same way. 12/5. What is that as a mixed number? 5 goes into 12. twice with 2 left over. So 2 and 2/5. So now I got to break it up into fifths. So I got 1, 2, 3, 4, 5. So 2 and 1, 2. 2 and 2/5. I like it. So if you make a mixed number, it makes it a little bit easier. You still have to be able to break up in the middle to find the exact fraction part somewhere in the middle. Bless you. But you should very quickly, if I just said between what 2 numbers is this fraction, between what 2 whole numbers would I find that?
2 and 3.
Yes, why? 8 goes into 16 twice, so 8 goes into 17 somewhere between 2 and 3. You should be able to answer that kind of question really quick. If I don't ask you for a number, I just say, tell me between what 2 numbers would I find this? 2 and 3. That could be a question that I would have sitting on the part of the test that won't allow you to use a calculator. Right, for example. Okay, I like it, maybe. Okay. Anything else from this 4142 stuff? How are we doing? Anything else from 4142? You guys alright? Remember, if you have a question, at least 8 other people have the same question. It's not just you alone. I worry about you guys. I do. Because not enough of you are coming to see me in my office, for example. Am I approachable? Am I a mean guy? I must be a mean guy.
No.
I am. I like some of you guys are like, it's like no matter how nice I am, since I'm associated with math, I am mean. It's like, oh great, what a life I've chosen. I'm mean. Okay. So no more questions from homework stuff? Alright.
The diagram. The B.
Which one? Sorry?
Diagram.
Which one was it again?
The 168. B. I know we can do like 1 and half.
Oh, so
Yeah, the diagram. Just like cooking.
again,
Yeah.
are you accessing the full book?
Yes.
Okay, so they've got examples. So I want to let you try that out on your own before I just give the answer one.
I know the answer, but I want to know how to like draw the diagram like this, or you want it to already number?
No. Diagram is different from a number line. Is that what you're asking?
Yeah, like this, right? The one. That's what I'm asking. Yeah.
So so they have examples where they show you the diagram. Right? I'm trying to leave something for people to do in their homework on their own. So you can come see me on your own. You've done the homework, you can come see me and we can talk.
Yeah, I did.
Okay. Not right now, but yeah. Okay. Anything else from homework? Okay. Oh, let me give you this here. Hold on. You won't know that. That's yours. Yours, right? Okay. Alright guys, so we're going to continue. Say it. No. So guys, I don't know if I've said this to everybody. I've said this to a few people. The hard copies of the book, they put it off again. So after this chapter 4, I'm going to try to see if I can't get our print shop and I can pay for it to make copies of chapter 5 through the end of the book, and then I can just give those out. I don't think it should be that crazy. I don't know if we have any, but we'll see. The math department might be able to pay for it. We'll see. I'm just not going to have you guys pay for it. So I'm going to work on that, getting chapter 5 through the end of the book printed out so you can actually have it. So again, I apologize that they didn't just tell me in the beginning that there was a chance this would happen. They said, yeah, we'll have it done middle of August. Maybe September. Maybe October. Shit. So, okay, so I'll try to do that. But hopefully, a lot of you guys are able to access it online. You can go to the Tech Mall, look it up, get the book online. You go to the Math Study Center, get it. They got computers in there. You can pull the book up. But I'll try to work on getting some hard copies printed out for everybody. Okay. All right. So last time we talked about all this stuff. We talked about mixed numbers. I showed you some freaky ways to do mixed number stuff, and some not so freaky ways, hopefully. Oh, good. Pull this guy up. Today we're going to get into adding fractions, subtracting fractions. But just to kind of go over what we did yesterday. Help me out here. Convert to improper. $11 3/7. So I talked about why the shortcut works. You don't have to do all that work I did. You just can use the shortcut now. But I desperately want people to know why it works. It's no good just knowing a bunch of shortcuts. That doesn't mean you know math. You need to know why they work. So what is the shortcut now? 7 times 11. Plus 3. 80. Don't say this. This is really neat. That's amazing. That's magic. I have $11 3/7. Now I have $80. So what am I missing?
7.
Yeah, 80 over 7. The over's got to still be there. So the work you do here is actually the work. Remember, just to remind you guys, here's the work we did yesterday. This needs a 7, right? 7 times 11 plus 3. So all this work here is to get the top. Do you guys see that? That 11 times 7 times 11 plus 3, that's just to get the top. The over 7 is still there. Right? Alright, don't be doing the magic. Or if you can, do it. Show me. I like that. Here's 2 1/4 cups, and now it's 9 cups. Holy crap, yay, everybody can have some. Alright. Let's see. Pull up the book real quick. I don't think we got into adding at all. We did some multiplying and some dividing, right? So, if I remember correctly. Did I show you guys? We definitely did something like this here. Let's just do, I think we did. How do you do this here? We kind of did this earlier in the questions people asked.
8 out of 15.
Beautiful. So 4 times 2 is 8. 5 times 3 is 15. I like it. To be honest, we've been doing this forever. What's 2 over 1 times 3 over 1? 6 over 1. I mean, every time you multiply any number anywhere, you are basically multiplying fractions, because every number is over 1. Alright, let me stop there for a second. Yes, ma'am?
But sometimes we can't do that because we have to have the same.
Okay, alright, I love it. Alright, so we're going to get into adding, subtracting fractions. And adding, subtracting fractions is much harder than multiplying, dividing. And a really good way to explain this requires me, thankfully we've talked about this already a little bit. Haven't we talked about like terms? Alright, and I'm sorry I got to keep checking with you because I have another class that sort of does similar stuff just in different pacing and it's weird. So like what would x plus x be? 2x. Totally. What are exponents based on? Multiplication. So am I multiplying?
No.
So the exponents won't change because I'm not doing the operation they're based on. What are coefficients based on? Addition. So I have one x and another x, so I got two x's. Later we'll see that x times x is x squared. I just put the two in a different place to show I have two x's, but they're doing something else. They're multiplying, not adding. So that's why I put the two in a different place. That really is the story. That's why it goes up there, just so because it needs to be somewhere else. Does that already mean something? Oh shit, we better put it over there. Now, what's my point with this? I don't know. Oh. So what's x plus x squared? Oh shit.
2x squared.
So not. I don't see 2x squares. How many x squares do you see up there?
That's x plus
I see
x
one.
squared.
How many x's do you see up there? One.
So it's x
Are they
plus
like
x.
terms? No. I like it.
So it's x
Now keep going with me. I'm getting a little ahead of us, but this really explains your question, because your question is a perfect one. Why sometimes the fractions need the same denominator, and why sometimes do they not? And it's like, and that's why people hate math. Math does different shit depending on what day it is. And no, never. If you think we're doing something different from what I did before, you're wrong. You need to come see me. You're not looking at it correctly. Don't just accept it. Does anybody know what x times x squared is?
2x.
1x times 2 more x's is x to the third. Now, again, are x and x squared like terms? No. So I cannot add them or subtract them, because addition subtraction requires them to be exactly like terms. Was I able to multiply them? Yes. So multiplication division is less stringent. They don't have to be perfectly like terms. So that's why I'm allowed to multiply these two, even though they have different denominators. I don't need them to have the same denominator. In fact, look at this here. What if it was, what is it, Jeff? You're all excited. Now, 7